Hello everyone, welcome to another lecture of the course Digital Signal Processing. In the previous lecture, we have looked at the need for real-time filtering operation, and we have seen one method, that is overlap and add method for the real-time filtering operation, in which we consider m length blocks of the signal where this m is the length of the filter. Then on each of these blocks we perform individual filtering, or what we call as the convolution operation, and then after performing that, in order to combine these output blocks, what we do is we consider the last m-1 points of the previous block and first m-1 points of the current block and just simply add them in order to have the final output. We had also seen that there is another method that is known as overlap and save method in order to perform the same operation. So now in this lecture, let us look at that method. So for this method, what we are going to consider is, we are going to consider the length of the filter as say m, and let the filter be given by this h of n, and we are going to split, or we are going to consider blocks of signal, or say input signal of length as L. So now let's say the ith block be given as xi of n, and now if we consider the convolution, say yi of n as xi of n convolved with h of n, then this yi of n will be having length as the length of this xi of n, that is L, plus length of h of n, that is m, minus 1. So this would be the length of the output signal that we are going to get for each block. Now in this method, what we do is we make the length of this h of n as well as xi of n equal to the length of this output signal, that is yi of n, which is L plus m minus 1, and instead of performing linear convolution, we go for a circular convolution. So we make length of xi of n and the filter, that is h of n, as L plus m minus 1, and then perform circular convolution. Now if we consider the filter, that is h of n, so that can be given by a sequence. So that can be given as a m length sequence as h of 0, h of 1, and so on till h of m minus 1. And in order to make it of length L plus m minus 1, so we are going to append L minus 1 zeros. So what we have is h of n as h of 0, h of 1, and so on till h of m minus 1, then we have 0, 0 and so on, and this is done L minus 1 times. And once we do this, the length of this h of n, so the length of this h of n is now m plus L minus 1. So the length manipulation for filtering is done. Now we need to do a similar thing for xi of n, but now instead of appending zeros, we do something else. So let's see what we are going to do. So this is x of n, which starts from here, which is split into L length blocks. So this is, say, my block 1, this is my block 2, and this is my block 3. Each is having length as length as L, and we need to change this length L to L plus m minus 1. So what we do is we consider m minus 1 points from the previous block. For example, if we consider this block here, so this block, which is shaded region, is basically of length L. So we consider this entire block as it is here. So this portion which we are having here, that is shaded one, is of length L. And in order to make it of length L plus m minus 1, we consider m minus 1 points of the previous blocks. So let's say these are the m minus 1 points of the previous blocks, and we consider them in the beginning of this current block. So what we do is consider m minus 1 points of xi minus 1 of n and append them at the beginning of the ith block or the current block, that is xi of n. So let's say the new block that we obtain, that is this entire block that we obtain here, be given by x hat of 2 of n. So let's say x hat I of n will be equal to, so the last m minus 1 points of xi minus 1 of n, so that would be xi minus 1 of L plus m minus 1 and so on till xi minus 1 of L minus 1. Then we would be having the L blocks or L points of the xi of n. So it would be xi of 0, xi of 1 and so on till xi of and so on till xi of L minus 1. And now this sequence which we are having here, that is x hat of I, is basically of length L plus m minus 1. And now we are going to perform convolution, rather circular convolution of this x hat I of n and h of n. So now perform circular convolution of x hat I of n and h of n. So what we have is y hat I of n is equal to x hat I of n circularly convolved with h of n, and again this y hat I of n would be of length L plus m minus 1. So now what we observe here is we are going to get this L plus m minus 1 points here, but now due to aliasing the first m minus 1 points would be incorrect and they would be corrupted due to the aliasing which we are going to have in this circular convolution, as we have some kind of overlap, or circularly fashioned shifting leads to some kind of overlap which is unwanted, which corrupts first m minus 1 points. So we just discard these initial m minus 1 points from each of the block and then simply append them. So once we perform this circular convolution, we discard initial m minus 1 points of y hat I of n, which are corrupted due to aliasing, and when we discard those points, let's say the new sequence would be given as xi yi of n, and then we just need to append all these yi of n in order to get the final output. So the final output y of n can be given as, say, yi minus 1 of n appended with yi of n appended with yi plus 1 of n, and so on. So this would be the final output that we are going to obtain. So now let us try to understand this using a simple example. So for that we are going to consider this x of n as 1, 2, 3, 4, 5, 6, 7, 8 and h of n as 1, 1. So what we will do is we will consider the value of L as 4 and we have the value of m as 2, which is the length of the filter. So the value of m plus L minus 1 comes out to be 4 plus 2 minus 1, which is equal to 5. Moreover, the value of m minus 1 is equal to 1. So that is 2 minus 1, so that is equal to 1. And now we need to split this x of n into two parts, each of length L equal to 4. So the first part, that is x1 of n, would be given as 1, 2, 3, 4, and the second part, that is x2 of n, would be given as 5, 6, 7, 8. Now we had seen that when we need to make them of length 5 or m plus n minus 1, then we need to consider m minus 1 points of the previous block. So we are going to consider this 4, that is 1 point of this x1 of n, the last 1 point of this x1 of n, and append at the beginning of this x2 of n. So x2 hat of n is given as 4, 5, 6, 7, 8, and x1 hat of n would be given as 0, 1, 2, 3, 4. Now we observe that before this one we don't have any kind of signal or any value of signal, so we are just going to consider m minus 1 number of zeros at the beginning of the first block. So these are the two things that we are having here. Moreover, we need to make this filter of length 5, so therefore this h of n can be given as 1 1 0 0 0. So now we have x1 hat of n, x2 hat of n and h of n. So next step that we need to do is perform the circular convolution. So now we need to perform circular convolution. So the first circular convolution, that is y hat of n, can be given as x1 hat of n circularly convolved with h of n, which is given as 0 1 2 3 4 circularly convolved with 1 1 0 0 0, and the output that we obtain here is given as 4 1 3 5 and 7. Similarly, y2 hat of n is given as x2 hat of n circularly convolved with h of n. So that is given as 4 5 6 7 8 circularly convolved with 1 1 0 0 0, and this comes out to be 12 9 11 13 and 15. Now we had seen that due to aliasing, the initial m-1 points are corrupted and we need to discard them. So therefore we have the value of m-1 as 1 in our example. So therefore we need to discard the first point from each of the block. So we need to discard this 4 from here and this 12 from here, and therefore the output that we obtain is given as y of n is equal to 1 3 5 7 9 11 13 and 15. So this is the value that we obtain here. So this is basically equal to 9, not 19. So this is the value of y of n that we obtain here, and this is the required filtered output. So in this lecture we looked at the overlap and save method, in which we consider L points, or if we consider the block length of L for the input signal, and then we append the last m-1 points of the previous block at the beginning of the current block, and then perform the filtering operation. And this filtering operation is basically done using the circular convolution, such that the filter is also made of length of L plus m-1 by appending L-1 number of zeros. Then once we perform the circular convolution, that is filtering, we found that the initial m-1 points of each of the filtered output are corrupted due to aliasing, and we need to discard them. So after discarding those m-1 points, we just need to append the remaining points in order to get the final y of n output. So basically for the real-time operations, we have looked at two types of operations or methods. The first one was overlap and add method, and the second one was overlap and save method. In both of these methods, we split the input signal x of n into some fixed length blocks and then perform filtering. So basically in overlap and add method, we split them in m length blocks, where this m is basically the length of the filter. Then we perform the filtering or linear convolution on each of this block, and then once we obtain the final output, which is this y1 of n, or the filtered output, which is of length 2m minus 1. So we observe that the last m minus 1 block of m minus 1 points of the previous block, as well as the first m minus 1 points of this initial block, are incomplete and need to be added so that we obtain the final values. So we consider last m minus 1 points of the previous block and first m minus 1 blocks of the first m minus 1 points of the current block, and simply add them in order to get the final value. But in case of overlap and save method, we consider the splitting of the signal into L length sequences, and we consider the length of the filter. So we consider the length of the filter as m. We consider that this L may not be equal to m. It may be equal to m, but it's not compulsory to consider it as equal to m. So what we need to do is we need to perform filtering on each of this block, but we are going to consider the circular convolution in this case. So if we want linear convolution of a signal of length L and a filter of length m, then the length of the convolution output would be L plus m minus 1. So therefore, if we want to use circular convolution, we need to make this L length block as well as this filter of length m as L plus m minus 1. So for that, in case of filter, we just append zeros, but in case of this block, in case of this x of n, what we do is we consider the m minus 1 points of the previous block and append them at the beginning of the block that is we are considering in the current situation. So the previous m minus 1 points of the block that was previously considered are now appended at the beginning of the current block. Then we perform the circular convolution and we obtain some values or some sequences which are of length L plus m minus 1, and we observe that the initial m minus 1 points in each of these blocks are corrupted due to aliasing. So these blocks are corrupted due to aliasing, and therefore we just discard them and append the remaining values or the remaining points in order to obtain the final y of n. So these are the two operations or two methods that can be used in order to perform the real-time filtering operation. So let's stop here. Thank you.